Welcome to Bovine Banter with the Penn State Extension Dairy Team. I'm Lisa Holden, an associate professor of dairy science at Penn State. Joining us today is John Tyson, an extension engineer with the Penn State Dairy Team. John, if you could please introduce yourself and tell us a little bit about your role at Penn State.
All right. Thanks, Lisa. Thanks for the invite. As you said, I'm a extension ag engineer with the animal systems team, the dairy team here. And in that role, mostly what I deal with is animal housing, mostly dairy, and other infrastructure things around the farm. So ventilation, cow comfort, heifer housing, those type things.
Thanks, John. So as we move through this series of season 16 Bovine Banter, we are focusing on heat stress. And this episode will cover information about fans, water, and facilities in order to help you develop the best strategies to incorporate heat abatement at the farm level. So let's get started with our discussion. John, how has the management of heat stress improved in the past few years?
Well, I think the biggest thing is that we now understand or have a better understanding of the need for heat abatement. That probably has gone a long way. And I think that's mostly been brought on by understanding or brought forward by the understanding that what happens without heat abatement, our loss of production, loss of breeding, foot health, the list goes on and on. So I think probably one of the better improvements I see in heat abatement is just the recognition on the farm that it is an issue and needs to be dealt with. Many of the technologies we use haven't really changed in the last 40, 50 years, maybe even. We've known how to do it. It's just the emphasis we now put on it because we recognize it as an issue.
So we're recognizing that issue of heat abatement. When you're evaluating a dairy's heat abatement program, where's the best place to start?
Well, I think it's a sort of a four-pronged thing. I start with a simple acronym to remember is SAAW, S-A-A-W. And we look at shade, air exchange, air velocity, and then water. And none of those four things, they're all integral parts of heat abatement. The shade is there to cut off the solar load, and we've got to do that to help the cow fight heat. Air exchange is simply the removal of the heat from the shelter. Tie stall, free stall, bedded pack, whatever the shelter is, getting the excess animal heat out of the building to allow cooler air in. Air velocity on a localized level right at the cow level. That's where we evaluate wind speed or air speed, directly at the cow at that 3-4 feet off the floor. That helps increase the heat exchange from the animal into the environment. And then finally, the water in two parts. One is using cooling water, whether it's misters or sprinklers. The other is to recognize that, cows consume more water during hot weather. They need it from a physiological, metabolic state. So we've got to allow more water space, more water availability during hot months than, say, January, February. So just remembering that's kind of the way I evaluate you. Look at the shade, look at the air exchange, look at the air velocity, then look at water availability. Can't really say one's more important than the other. It's just they all have to work together.
So you're talking about air exchange and air velocity. What are some different options for fans, and what are some advantages and disadvantages?
I think before we start talking about the fans themselves is to kind of get a basis of what this air exchange is. And that's where we have to start. Like I said, that's removing the heat from the shelter. So if these are fans that are wall fans, think tunnel ventilation, cross-ventilated buildings, where we're exchanging the air mechanically, bringing fresh air in, stale air or hot air in the barn out, that's one style of fan. Other fans are circulation fans that are increasing the air speed within the building, but we really have to look at that natural ventilation first. That would be the typical here in Pennsylvania and most of the Northeast is naturally ventilated structures. So we got to maximize the natural ventilation before we start talking about circulation fans. So I always look to, what are we maximizing the openings of the sidewall, maximizing the exposure of the building to natural breezes. Then we get into, that is trying to increase or maximize the natural ventilation air exchange. So now once we get the heat out of the building, now we add circulation fans to increase the local wind speed. And really the big two that we use here in the Northeast are axial fans, large panel fans, usually some as small as 3 foot, others as large as, 52 inch, so 4 foot 4 inches. And what we're really trying to do is increase that airspeed somewhere in the 4 to 6 mile an hour or higher range. And, air moving over a cow increases her ability to give off heat into that airstream. So increasing the airspeed. The other option we have are large HVLS, high volume, low speed fans. Overgrown house fans, anywhere from as small as maybe 12 foot in diameter to I think the largest ones are 24 to 25 feet in diameter. There are name brands I won't mention, but universally we call them high volume, low speed fans. And they're attractive from the standpoint of there's a lower energy input, electric input than multiple axial fans, the normal circulation panel fans, but they have a limited speed. It's right in their name, and I always remind people it's a high volume, low speed fan. Both the blade itself is low speed, and the airspeed is on the lower side of what we're looking for. Often, that 2.5 to 3 mile an hour at most is all they'll create. So they can be somewhat limited in getting enough of airspeed. Way more attractive to bedded pack barns, larger open spaces, really compact, high density, think 6 row, 3 row, multiple row buildings that are very densely packed with animals or populated. I personally like the panel fans. Yes, they're going to have more electric use. We're going to get more bang for them. But those are our two options. When we look to mechanical ventilation, like tunnel ventilation or cross barn ventilation, the fan technology has really moved forward mostly in motors, dealing with direct drive, EMC, electromechanically controlled motors. They're considerably more efficient than what our old belt-driven inductive motors were. And that's kind of, I'm not an authority on it, but I know that you have to you do your due diligence when we're looking at these fans, and there are some advantages to that type of fan from an energy use standpoint. So we're getting better looking at energy efficiency. I warn people when it comes to fans, the one thing I will warn you is you get what you pay for. Not that I'm promoting the most expensive fan, but some of the discount fans have lower quality components. Therefore, they are less efficient. And the money you save up front in capital, you pay for the next 3 to 4 years in operational costs because they're going to burn more electric, creating a higher electric bill.
So great information about fans. What are some good options for sprinklers and misters? And what do we do if water is limited?
Well, first of all, on sprinklers and misters is to, kind of understand what you want to do. Misters are it boils down to direct versus indirect cooling. Indirect cooling would be a mister system where we're trying to cool the air, lower the the temperature of the air, and then us use that to cool the cow. Direct cooling, we're wetting the cow to the skin. So think of us there, we're talking about sprinklers, aka soakers, and we're wetting the cow directly to the skin, using the heat from the animal to evaporate the water, or most of it. Most of the heat is coming from the cow, so it's direct cooling. Sprinklers will tend to use more water than misters. If water is limited, there are some approaches. That's the attraction to the mister. The other thing is where we put those soakers. Look at things like putting them in the holding area first rather than over the feed bunk. Um, you will you'll get more use of the water because it's in a holding area. Cows are crowded together. It's pretty hard to spray water and not hit a cow. Feed bunks, the downside of that is that about half the water that goes through a fence line sprinkler winds up in the manure system. So you kind of are wasting water to a certain extent because now we're adding it to the manure, not using it. There are other controllers out there now available that have a small electric eye on the sprinkler itself, on the nozzle, so it won't turn on if there's not a cow present under the feed bunk. So when you're in the barn, you'll see pieces of the system come on. If there's 4 or 5 cows eating, it'll soak them. If there's no cow at the feed line under that sprinkler won't be allowed to come on. Um, some of the industry says they can save 30-40% of water use. I haven't seen any university studies to back that up, but I can believe that there is water savings because the nozzles are just on less. Um, I think here in the Northeast, it's not so much water availability as it is dealing with that extra manure. That's the challenging part. A couple years ago, I did back of the envelope calculations, and if I assumed half the water went into the manure system, I needed a half a pound of milk per cow to justify hauling that water away as manure. Now that's assuming that I had the water and I wasn't on a limited water source. We get into parts of the country where it's limited. They are much more attracted to indirect cooling, where we cool the air down and then circulate that through the barn. Um, but I think the first thing I would say is focus on the hottest spot in the barn, which is going to be the holding area.
Thanks, John. So, continuing on this topic of water, what about fresh water for cows, both during times of heat stress and at other times of the year? What's optimal?
Usually when I'm looking at barn designs anymore, I'm trying to equate it down to like we look at feed bunk space, and trying to have somewhere around at least 4+ inches of water space per cow, um, in the barn. So look at linear feet of water space. 10-foot water is 120 inches. That would be 30 cows could, every a water, 10-foot water for every 30 cows kind of thing. Um, the other is in the summer, because water isn't going to freeze, maybe we add waters around other places in travel lanes at the exit of the parlor, travel lanes from the parlor to the freestall, or vice versa. If you have exercise lots or pastures, to have extra waters that could be as simple as, garden hose and a tub. Don't have to worry about it freezing, so it can be pretty low cost to add a few extra waters around the farm in the summer that then can be removed in the winter. Um, Even in the winter, water is important. Milk is 87% water, so that water has to come from somewhere. But I think really just identifying or understanding that water consumption in the summer is probably going to go up by 50% or more, just because cows naturally drink more when they're warm than they do when they're cold, lead you to believe that you need more water in the summer.
Thanks. So you talked about soakers in the holding area. That holding area is such an important place for heat abatement. How can we do a better job there overall?
Well, I think it's back just like to the shelter. Think about the SAAW, shade, which obviously is mostly going to be there. Very few holding areas don't have a roof over them anymore. But look at air exchange and air velocity along with soakers. So how can we maximize sidewall openings if it's naturally ventilated, or can we force ventilation in, whether it's positively force air in through sidewall fans or tunnel ventilate it, whatever we want to do to maximize the air exchange and get that heat out. Holding area, very small area, can have 100 or more cows in it. Tremendous amount of heat. We need air exchange, one probably down in that 30-second air exchange rate to really get the heat out, and then increase air velocity. And like I mentioned, soakers are probably the best option. Intermittent soakers, on for a minute, off for 5, somewhere in that ballpark, soaking cows, because it's, you get more bang for your buck, where we're going to soak that cow, dry her off, soak the cow, dry her off. And that, going back a little bit, that's probably the other important thing to understand in soaking cows. It's not making her wet that cools her off, it's the drying that cools the animal off. We have to soak her, then dry her off, and the evaporation of that water is what pulls the heat out of the animal. So you don't want to have them under constant barrage of water. The water needs to run for a short amount of time, then be turned off long enough for the animal to dry off, then soak her again.
Thanks, John. Lots of good, timely information. Do you have a take-home message that you'd like to leave for our listeners?
I guess my take home message is that, high producing cows are going to generate a tremendous amount of heat. And I think that's the other part we're now understanding, is that to have a 100-pound cow that makes 100 pound of milk a day, she's going to eat a tremendous amount of feed and generate a tremendous amount of body heat. And we've got to deal with that heat within the building and get it out of the building, bring fresh air in, and keep that animal cool. So I think getting that heat out, that would be my take home message, is to really think about the amount of heat these animals are producing, and that'll give you an understanding of why we want to push so hard at heat abatement in the summer months.
Well, thank you very much, John, for talking with us today. And thank you again to all of our listeners. This is the last episode in this series on heat stress. So please look for the next Bovine Banter series coming very soon. Thank you, everyone.